Okay, so recall that when we did division with regular old fractions, when you divide by a fraction, you multiply by the reciprocal. So when we divide by a rational function, right, what we're going to do is the first step is we're going to recognize that this division means that we need to flip it and make it multiplication. So before I factor anything, I'm just going to rewrite this problem. So I rewrite exactly what I have with it as multiplication instead, and then you're doing the same problem we just did in the other examples. So I make it multiplication, this x squared minus 4 becomes the top, and this x squared minus 9 becomes the bottom. And now, this is just like example 2. Right? So it's the same idea as example 2. Now I just factor everybody, right? So again, as you factor, you'll get better at this, right? But this is one of the reasons that I wanted you to get quick at factoring. I'm going to argue that the two easiest to factor are the difference of squares, so I'm going to do them first, right? So I'm going to start with this one and recognize that this is an x plus 2, x minus 2, right? I'm going to take this one and recognize that this is an x plus 3, x minus 3. So now I do that largely because now when I'm factoring the others, I can look for factors that will likely cancel. So I look at the x squared plus 7x plus 12, and I think, well, 12 is probably a 3 times a 4. They're the same sign, and that sign is positive, so I get an x plus 3 and an x plus 4, and you can confirm that by FOILing in your head, right? You can confirm that you get a 12 for your back seat and a plus 7x in the front. And then for the last one, right, 8 is either a 1 and 8 or a 2 and a 4. Because I want a 6, I'm going to guess that it's a 2 and a 4. Both signs are positive, so same sign, and then both signs are positive, so I get an x plus 2 and an x plus 4, right? So then the game is just cancel what you can, right? So if we go back to the highlighter for a sec, an x plus 3 cancels with an x plus 3, an x plus 4 cancels with an x plus 4, an x plus 2 cancels with an x plus 2, and my final answer is just those two factors that didn't cancel. So my final answer is x minus 2 over x minus 3. And that's it. So again, the trick with division is to flip the divisor and make it multiplication first. All right, so go ahead and give P3 a try, right? Remember, before you do anything else, your job is to flip this and make it multiplication, right? So flip the divisor and make it multiplication. So I have an x squared minus x minus 12. I would suggest you do this before you factor anything, because if you factor first, you sometimes accidentally try to cancel things from the wrong floor. So please do the flipping before you do the factoring. You'd be surprised how many times you accidentally cancel something you're not supposed to cancel otherwise. All right, so if we factor this, I'm going to start with the easiest one. The difference of squares is totally the easiest. So I'm going to start with that one and say, cool, that's an x plus 10, x minus 10. Part of the reason to do that is I now have an incentive to look for those same factors somewhere else, right? So let's go ahead and do this one next, right? I need something that multiplies to a 3, which is pretty much just a 1 and a 3. The plus tells me they're the same sign, and then this plus tells me what the sign is. It's a positive, so I get an x plus 1, x plus 3. And sure enough, if you FOIL to check, you'll see that you get a 4x in the middle. When we factor this one, right, I see that I haven't gotten any 10s yet. It's really likely I'm going to end up with a 10 because you see the x plus 10 and x minus 10 on the top. So I'm guessing that this 40 is a 4 times a 10, right? I'm guessing that based on the information I have up top already. So sure enough, if I do an x plus 10 and an x minus 4, that gives me the negative 40 I want, right, the opposite signs, and it gives me a plus 6, all right? And then when I go to factor the last one on the top, I say, cool, it's a 12. It could be a 3 and a 4, a 1 and a 2, a 1 and a 12, or a 2 and a 6. But I say, hey, I think it's a 3 and a 4 because they have opposite signs and I need a negative 1. So I need an x minus 4 times an x plus 3. And again, you should FOIL in your head to make sure that you get x squared minus x minus 12, because sometimes you're going to factor wrong. I did it on example 2. I factored this one wrong the first time I did it, but it was a silly mistake, and it was far enough into the problem that it would have been a lot to keep it in the video. But I want to point out that I accidentally made this 5 into a 2 times 3, which is not how you get 5, for the record, right? We all do it, so please FOIL to check your stuff. So once everything's fully factored and I FOIL to check, we'll go back to the highlighter to cancel some stuff. All right, so I see the x plus 10 cancels with an x plus 10, x plus 3 cancels with x plus 3, x minus 4 cancels with x minus 4. Oh, look, I'm just left with the x minus 10 on top and the x plus 1 on the bottom. So my answer is x minus 10 over x plus 1. All right, moving on. All right, so the last type of this problem we're going to do are what are called complex fractions. This is the same concept as the one you just saw here, right? We have a divisor. The difference is that this long division bar, right, that's the same as this division symbol right here. So what's happening here, if you need this step, is this is a 2x squared minus 5x plus 3 over x squared minus 1 divided by this thing. I didn't flip it because it's still division, right? I'm just writing division in a different way, right? So this is still division. That means that this is the thing that has to get flipped, right? So I have to flip this to multiplication. So I get that this is a 2x squared minus 5x plus 3 over x squared minus 1 times, and then I flip this guy, 2x squared plus 3x over 4x squared minus 9. Now, if you were able to jump from here to here, is that cheating? Nope. It's okay to jump, right? It's always okay to make that jump, but if you find that you're having trouble doing so, then don't do it, right? So let's start by factoring the ones that I would argue are easiest. So I'm going to make the argument that the easiest of all these to factor is this one because it's a nice, easy difference of squares. It's arguably the easiest difference of squares. It's x plus 1, x minus 1. I'm also going to argue that this is a fairly easy difference of squares to factor, right? Because this is a 2x quantity squared minus a 3 squared, so 2x plus 3, 2x minus 3, right? Those are both differences of squares. This guy just has a GCF, right? He has an x and then a 2x plus 3, which is convenient because, look, there's that 2x plus 3 on the bottom, right? And then the last one to factor is this guy. I know that the 2x squared at the front means that one of the seats is going to have a 2x and the other one's going to have an x, right? I see this 3 at the back, and I know that that has to be a 1 and a 3 with the same sign, right? Because the plus says same sign, and that sign is a minus. So I know these are both minuses. Now, I'm going to make an educated guess that the 3 is going to go in with the 2, because with the 2x, because look, I already have this 2x minus 3 on the bottom. So again, the advantage to factoring the easier stuff first is it helps inform your factoring moving forward. So I'm going to try the 3 here and the 1 here, and then I'm going to FOIL to check. My first is a 2x squared, that's right. My outer is a minus 2x and my inner is a minus 3x. Yep, there's my minus 5x, and my last is a plus 3. Notice that this x is not multiplication. It's an x like the variable x. Please don't use x to mean multiplication at this stage of math. It's not a good idea when you have x's. It's not so much that you're at this stage of math, it's that x is very frequently a variable. If x is a variable, do not use x to indicate multiplication. You can't do that. If x is a variable, that's not an option, okay? So now when I go through and cancel, I see the x minus 1s cancel, the 2x plus 3s cancel, the 2x minus 3s cancel, and I seem to just be left with that solo x on the top and an x plus 1 on the bottom. So my final answer is going to be an x over an x plus 1, and that's it. All right, let's go ahead and do one last problem, and that's it for this video. So same issue. This is your divisor. If you are able to comfortably flip, right, if you're able to say, oh, I get it, I flip the divisor, that's great. If you can jump down to this step where you say x squared minus 5x plus 6 over x squared minus 4x plus 3 times, and then you flip the divisor, that's great. Cool, I'm fine with it. If you can't do that, if you need the step in the middle, so that's fine, right? But if you need the step where you say, oh, I get it, this is x squared minus 5x plus 6 over x squared minus 4x plus 3 divided by, and then keep it the same. If you need this step before you flip it, that's also fine, right? How much work you personally need, right, is going to depend on you, right? So if you need this step, if you need to have that step to get here, that's fine. If you don't need that step, also fine. You need to learn to show the appropriate amount of work that's going to make it doable for you personally. So when I go to factor, I'm going to start with the easiest one, which I'm going to argue is this difference of squares. Right, x plus 2, x minus 2 means I'm likely to see either an x plus 2 or an x minus 2 on the top. I'm then going to go, I think, to this guy because I see the 1 and the 9, and I think, hey, I know it could be a 3 and a 3, but 1 and 9 is definitely going to give me 10. So x minus 1, x minus 9, right? This tells me they have the same sign. The minus tells me the sign. And you can FOIL to check to see that you get a negative 10 there. I'm going to go ahead and factor this guy next, right? So that's an x minus 1, x minus 3, right? Because I need something that multiplies to 3. They have to have the same sign, and that sign is negative, right? And sure enough, if you FOIL, that pans out. And then for the last one, So I can either use a 1 and a 6 or a 2 and a 3, but because they have the same sign and I need a -5, it's the 2 and the 3. The other way I can spot that is because if I look at my factors, there are no ones, there are some 1s, but there are no 6s, right? It's very unlikely. So it's very unlikely to be that other factor. So there's all my factors, right? X minus 2 cancels with x minus 2. X minus 3 cancels with x minus 3. X minus 1 cancels with x minus 1. And my final answer is going to be the x minus 9 on top of the x plus 2. And there you have it. All right, so that is 8.3.